In this video, we're going to talk about the difference between absolute maxes and mins versus relative maximum and minimums. And keep in mind that the word relative can be interchanged with the word local here. It could also be called the local maxes and mins. So an absolute maximum or minimum is when we look at the graph in its entirety and we look to see where the highest point is on the graph. Now keep in mind sometimes that doesn't happen. Sometimes we don't have a highest point where the range is from minus infinity to infinity, and so there isn't a absolute max or min. But if there is an absolute max or min, that's where you look to see what the highest point is on the graph of the whole entire graph and the lowest point of the entire graph. So when I look at the first example here, if I look, the highest point on this graph is at y is equal to 16. So I would say we have an absolute max of 16 at, and this actually occurs in two different places. It occurs at x equals -2 and at x equals +2, here and here. Now the absolute minimum value, if I look at the whole entire graph, where it is the lowest on that graph would be right here at this dashed green line. So I would say we have an absolute minimum of -10 at x equals 3. Now the local or the relative maximum and minimums are going to be where you see the tops of the hills and the bottoms of the valley. So they might not be the lowest point on the whole graph or the highest point on the entire graph, but they're going to be the highest and the lowest point in that area of the graph. So if I look at this point right here, this is called a local min, where I just made a red dot. And this is a local or a relative min because it's not the lowest point on the entire graph, but in this area right here, in that area of the point surrounding that point 0, 0, that is the lowest point in that area. So I would say I have a relative minimum of 0 at x equals 0. Okay, now the relative maximums are going to occur at the tops of the hills. So if you look, the top of my hills here and here, in this area of the graph, those are the highest points. So I would say I would have a relative max of 16 at x equals -2 and x equals +2. Now, as you can see, sometimes the absolute values and the relative values can overlap and they can be the same thing, but that doesn't always happen. Okay, let's look at the next example. It looks like we have a relative min, because it's the bottom of a valley right here. So a relative min of -2 at x equals -1. And I have a relative or a local max of, let's see, 2 at x equals 1. Now, if you notice, this is one of those special cases where there is no absolute max or absolute min, because these arrows tell me my range goes from minus infinity to infinity. So there is no bottomed out point or a point that it tops off at. It keeps going forever in both directions. Okay, last graphical example. Like, see, it looks like I have a relative min here and here. So I have a relative min of -1. Whoops. So I have a relative min of -1 at x equals 1, and I have a relative min of, let's see, that looks a little bit less than 1, so let's call it a half. A relative min of a half at x equals 4. And then we have a local max right here, a relative max at, that looks like at 1 when x is 3. So those are our relative or local maxes and mins. Those are the bottoms of the hills and the tops of the valleys. Now, if you notice, my arrows here say I go up forever, so I have no absolute max. However, I do have an absolute min. If I look right here, this is, if I look at the entire graph, that point, 1, -1, is the lowest point on my graph. So this is a case where my absolute min and my relative min overlap. So I would say I also have an absolute min of -1 at x equals 1.